Hello, in this video we will work on different arithmetic operations performed on NumPy arrays. It's exciting, right? So let's get started. So we have seen some different ways of creating arrays by using some special functions like zeros, ones, identity I with the help of full. We have also converted them into another with the help of given array. We transform them into ones, zeros by using like functions, right? So that's how you can just make it practice. Now let's try to go with some basic arithmetic operations which are possible over arrays, because when that's the main difference which we have seen, because lists cannot perform this element-wise operations, right? But when we go for arrays, because arrays are important, they enable you to express some operations on data without writing any loops. That's what we have seen in the beginning. If you could just remember, in the starting videos we have mentioned how do you perform addition. When you go for a list, you need to go for taking the values out of the list and perform the addition, subtraction, whatever it is. But when you go for arrays, you need not go for taking out the elements, because arrays call this way basically vectorization. They perform some element-wise addition, subtraction, multiplication, division, everything, right? So now let's work on basic arithmetic operations over NumPy arrays. Arithmetic operations on NumPy, or arithmetic operations on NumPy arrays, where first we'll perform on a single array. I mean, we need not we'll work on a single array, and then we'll go for taking multiple arrays and perform some arithmetic operation, because generally any arithmetic operation between equal size arrays will perform element wise. That means if I give arr is equal to np dot array of, it's up to you whatever you want to throw. If you want to use above thing, it's up to you. I am creating a new array 1 2 3, so that if you write more number of times, you'll get practicing, because you don't make mistake. That's what I learned, and that's what I suggest people. It's whatever you feel, just go on writing the code, whether it is your IDLE or any other environment, whether you use PyCharm or Jupyter, Google Colab, whatever it is, just whatever comes into your mind, just execute it. That's it. Don't worry about whether it is right or wrong. You learn it from debugging, right? So first, if I try to add the element, something like if I give arr plus 2, so as I mentioned, it performs element-wise addition. So 1 plus 2 is 3, 2 plus 2, 3 plus 5, 4 plus 2, 5 plus 2 is 7, 6 plus 2 is 8. So in that way, you could perform element-wise operation when you go for addition, subtraction, arr minus 2. In the same way, you could go for all operations by multiplication. When I give arr into 3, element-wise, 1 into 3, 2 into 3, 3 into 3. It depends on the array what you have mentioned, whether it is 1 dimension or 2 dimension. And if you go for floating division, because slash is for floating division, which we use in Python, so you get the values in float. The same way, if you want to have exponential, what you try to do, you just give double star. So double star of 2, we generally use double star for exponential operator. This is so because already we have studied that thing in Python operators. So when you go here at double star 2, so 1 power 2 is 1, 2 square is 4, 3 square 9, 4 square 5 square 6 square, right? That's already you have just learnt on it. And in the same way, for division operators, we have, when you give arr double slash 2, this is flooring division. It returns you only integers, right? So 1 double slash 2, 2 double slash 2, 3 double slash 2. This is flooring division, and you perform modulus. Everything is, because whenever I say arithmetic operation, you need to work on all of them, right? Modulus returns you the remainder. That's it, right? We already know that part, because double slash is flooring division. So double slash is generally called as flooring division, and percentile is, so when we go for percentile, it is modulus. It returns you the remainder. This is on a single array, right? Now what we'll do is, we'll try to create another array and perform operation on this. So I'll just name it as arr1 is equal to, I'll just give np dot array of, make sure they have same size, right? If they don't have same size, you will get an error. I'll just make it clear. So 4, 5, 6. So I'll just execute this arr1. You could see arr1 is 4, 5, 6. I'll give arr plus arr1. So when I throw this, you could see the difference. So you did not get error, but what happened over there? Element-wise operation is being performed. right? That's where we'll understand this concept in broadcasting. Just don't worry, you will not get any error. That doesn't mean that everything is perfect, but you need to just get the logic what happened over here. So I print the previous one. So 4 plus 5, 5 plus 2, 6 plus 3, 4 plus 4, 5 plus 5, 6 plus 6. Right? That is how broadcasting comes into picture. So because whenever we go for broadcasting, automatically NumPy arrays will adjust to the shape. Right? So to make it more simple, what I'll do is I'll pass some values so that ARR1 and ARR2 will be of, see, this is 2 by 3 and this is 2 by 3, so that you can easily understand. That is my intention. So in the next video, we'll be working on what happens if I give shape differently when I try to perform arithmetic operation. That's what we'll be seeing. So just need not worry, go with the same arithmetic operation. So ARR plus ARR1, well, how many number of arrays you have, you can just go ahead. So ARR plus ARR1 is 1 plus 4. Perform element-wise. That is the reason NumPy users call this as vectorization. This is very, very important. 5 plus 2, 7, 6 plus 3, 9, 7 plus 4, 8 plus 5, 9 plus 6. Even though you did not give the same shape previously, you got the result. That is where the beauty of arrays is. Right? You can also get the addition by using a function called as add function. np.add. It will automatically take, see, it is expecting 2 arrays and you have some out is n-dimensional array where. So first let's give 2 arrays. What are 2 arrays? ARR, ARR1. So now you would see the same result what you got above. See, 5, 7, 9, 11, 13. It's all about whether you use the symbol or whether you use the function. It's up to you. So if I want to perform subtraction, I just throw ARR minus ARR1. Then you could see, so it is 1 minus 4, because you are giving the less number with positive number. So you got all negative numbers because you gave ARR minus ARR1. So this is my ARR1 and this is my ARR. So 1 minus 4, 2 minus 5, 3 minus 6. So if you want to get positive, what you should do? You should make sure ARR1 minus ARR. So all the things will be positive. 333. Or you can also use the function called as, if add is present, you will have subtract also. So if you want to go for subtraction, you can just give ARR1. Make sure you mention the arrays ARR1, ARR. You could see the same result what you have thrown. This is for the subtraction, because these are all basic arithmetic operations which are possible over an array. Because we have seen on working on a scalar. So previously that scalar will just make sure, scalar in the sense we have mentioned only one value, only a one-dimensional array, and we are taking any scalar. So it is going element-wise. If you take multiple arrays, you go element by element in both the arrays. So this is addition, subtraction, and if you go for multiplication, this multiplication is not the dot product, it is different. Because when you go for dot product, it performs with the shape. So when I gave ARR into ARR1, so what is ARR? This is my first array. So 1 into 4, 2 into 5. 1 into 4 is 4, 2 into 5, 10, 3, 6 is 18. See, you should get 4, 10, 18. That is element by element multiplication. The same way you have a function called as np.multiply. So these are very basic when you perform on, when you go for arithmetic operations over an array. So multiplication, you could just give ARR, ARR1. It's all about how do you use, whether you use the keyword, function, or whether you go for the symbol. It's up to user interest, right? So this is element by element multiplication. But you have another function called as dot. So that is where linear algebra comes into picture. That means if I go for np dot of, so np dot product, see dot product of two arrays, that means specifically the shape should match. So it is 2 by 3, 2 by 3, right? You should get an error. Let me throw it ARR, ARR1, because it will throw you an error. You see, values shapes of 2, 3, 2, 3 not matching the dimension, because if you remember matrices property, the number of columns in first matrix should match with number of rows. Here it is 3, here it is 2. That is the reason you got an error here. That means you need to transform your ARR1, or what I'll do is I'll create another array like this, b equal to np dot array of, that means I should have at least 2 by 2, right? So I'll pass 1, 2, 4, 5. That means when I go for b dot shape, so b dot shape will be, it is 2 by 2, and if I go for ARR dot shape, it is I think it is 2 by 3. So 2 by 3, 2 by 2. Again, it is not matching. But what I can do, B into ARR, right? I can do like this. NP dot of B comma. So B is 2 by 2, ARR is 2 by 3. So number of columns and number of rows are matching. There you go. So B comma ARR. So you got it as 9, 12, 15, 24, 33, 42. But how did you get it? Let me make it very simple. So first let's write both ARR and A. So I'll just take a new code cell here within this. So you could see when you give print of B, and let me print in the same way. So print of ARR. So when I print both of them, you could see both of them. So 1, 2, 4, 5, 1, 2, 3, 4, 5. This is similar to your matrices operation. So to make it very easy to understand, I'll use my paint tool. Don't worry, because this is not element by element multiplication, but row and according to the column. Because we gave B comma ARR, how did you get the first element as 9? If it is element by element, that is different, because when you go for np dot multiply, you could see the difference in the result. When we get np dot multiply of B comma ARR, you may not sure whether you get result or not, but you will get an error. Why? It tells you 2 by 2, 2 by 3. Okay, because B is 2 by 2 and 2 by 3. You may try by giving ARR comma B. Let's see what happens over there. When I give ARR comma B, when you give ARR comma B, you could see again 2 by 3, because the number of columns are not matching, right? To easy to understand, I'll show how does this dot product has been performed. Let me use my paint tool so that you could easily see. So we'll write first what is our B array. B array is 1, 2, 4, 5. So I'll just make sure I'll give 1, 2, 4, 5. So the shape is we have as 2 by 2, that is 2 rows, 2 columns. What is the next array we have taken? We have taken it as 1, 2, 3, 4, 5, 6. So we have taken 1, 2, 3, 4, 5, 6. As we have mentioned, when we go for dot product, it will only check for the number of columns and number of rows. So first the number of row columns is 2 and number of rows is 2. So both of them are matching. So the resultant will be 2 by 3. So how does this is perform? Right, it will take this first row and first column. So 1 into 1 is 1, 2 into 4 is 8. So 1 plus 2 into 4, 8, that is 9. That is the result. You got the first element as 9, right? Because you go with row and the column, right? The next thing is 1, 2 and 2, 5. 1 into 2 plus 2 into 5. 2 plus 10 is 12. So the second element is 12. The third element is 1 into 3. 3 plus 12, that is 15. Next thing, 4 into 1 plus 5 into 4. So 4 into 1, I guess it's 4, right? So 4 into 1 plus 5 into 4. 4 plus 20 is 24, right? You got it the same? Yes, 24. And the next thing is 4 into 2. 8 plus 25. 25 plus 8 is 33. Then the next thing is 4 into 3. 12 plus 30 is 42. There you go. You got 9, 12, 15, 24, 33, 4. Just remember the matrices operation. Just you go with row and column. Row and column. Perform row column wise and add each and every element, because that is similar to matrix operation. You get 9, 12, 15, 24, 33, 42. That's how you got the same result. This is dot product. And multiply, when you worked on multiply, it gave you an error because it cannot broadcast together because the shapes are not matching. That's where the difference, which we'll understand about broadcasting in the next video. So just keep an eye when you are using dot product, make sure the number of columns and number of rows are matching in both the arrays. Because when you give np dot of, you try to give ARR comma B. You see what happens over there? It will clearly throw you an error because it is 2 by 3. The number of columns are 3 and number of rows are not matched. Just make sure when you're working on dot product, keep it very simple. Right? So that is about dot product. And let's go back for the division operation. When you go for print of ARR and print of ARR1, so that you could understand. So these are 1, 2, 3, 2 by 3 and 2 by 3. Whenever I perform division, ARR slash ARR1. You can work on flooring division, that's up to you. 1 by 4, 2 by 5, 3 by 6. And we can also use one more function, which is divide. So when you go for np dot, it will throw you the available function. In that you could take divide. You have so many things, just make it working accordingly. So I can give ARR comma ARR1. So when I press shift enter, you could see the same result. Whether you use the symbol or go for the function, it is same. That is how basic arithmetic operations. When you work on a scalar or when you work on the basic multiple arrays, you could see the difference, right? And even we can compare both the arrays, right? Suppose if I give ARR is greater than ARR1, it performs element-wise comparison. 1 greater than 4, it is false. 2 greater than 5, it is false. You could just compare it. 2 greater than 5, 3 greater than 6, everything. If you want to get ARR less than ARR1, you could see the difference. It is everything is true, the vice versa of it. So that is how we have understood when working on scalar and when we're working on multiple arrays, you could see the basic arithmetic operations, and this is very much easier. But you could clearly understand the difference between multiply function and dot product function, because dot product is similar to matrix multiplication. When you go for multiply function in NumPy, it is element wise multiplication. Because in the next video, we'll be working on the concept of broadcasting, because operations between differently sized arrays is called as broadcasting, and NumPy supports it very widely. So just keep on practicing with this arithmetic operations. If it is very simpler, but when we working on the Excel sheet, you extract the columns, we do the same thing. If you are good at the basic things, then it will be very much easier when you work on an Excel sheet, when you go for analysis, because analysis is very important, where we try to clean, load and transform on the data. That's a very important step. So just make sure you are good with the practice, and any queries, I am there to help you out. So in this video, we have understood how to perform arithmetic operations on a single array and also on multiple arrays. In the following video, we will work on broadcasting in NumPy. Thank you. I hope you have enjoyed watching it. If you have liked our content, please do hit like button and do subscribe to our YouTube channel for more useful content and exciting updates. If you want to learn such practical content at an affordable cost with Microsoft certification and instructor support, please register at academy.codegnan.com. You can also download app from Play Store as Codegnan. Never hesitate to raise queries in the comment section, and please do reply with your suggestions for more practical videos. We'll be happy to come up with it. Thank you.